Okay, let's get started with the ERC-721 video where we'll learn how to deploy an ERC-721 contract on the Hedera network using the JSON RPC provider and using OpenZeppelin to create our contract. We'll also interact with the contract to mint an NFT. First, let's set up our project. Let's initialize the project. There we go, and the project has been initialized, and now we need to install a couple of dependencies. First, let's install a couple of the base dependencies. So I want to install the OpenZeppelin contracts because we need these helper contracts for our ERC-721 contract to work. We also need .env to load the JSON RPC URL and also our account to pay for the transactions. And finally, we will also use ethers. So we need to install this package as well. Further, we will use Hardhat. Let's save this as a dev dependencies. And lastly, install some extra dependencies as a developer dependency from Nomic Labs for Hardhat script execution to interact with our smart contract. This last dependency can take a while to install. And that's it. So now let's create our .env file. And in the .env file, we will actually store, first of all, the operator ID, then the operator key. This is the hex encoded one. Make sure to replace it with your key. And finally, the JSON RPC URL. As we're just testing things, let's use the one hosted by SEO or the testnet.io/API. There we go. Next, we need to create our index.js file. First, let's load the right dependencies in our .env. Next, I want to be able to verify if our JSON RPC URL is correct. It's just a simple check. And then we will use the ethers library to create a new provider and to connect through our JSON RPC provider. And we will use this Web3 provider to retrieve information from the Hedera network. So then let's add some more code and call this the main function, where we first try to retrieve the block number from our Hedera testnet and print it to the console. And then next, I want to retrieve the balance of our account. So this is my hex encoded account address. Replace it with your own account, and then we print the balance to the terminal. So we can actually verify if our JSON RPC provider is working by executing this file. So let's use a node index.js command to execute it, and it will print the block number and the balance for our account to the console. Next, it's time to start with our hardhat.config.js file. Here we will actually store the config for connecting with Hedera testnet, so the Hardhat tool can actually understand this. So let's import the .env file because we need to import the JSON RPC URL again. And then let's create our base object. We fill in some basic details, for example, which version of Solidity we're using and some other settings that we want to optimize. And then we need to specify the networks object. Here we can specify the different networks we want Hardhat to be able to access. Let's configure a network called testnet, which will connect to the Hedera testnet. We will set the JSON RPC URL from our environment variables. And I will also provide one account in the array, which is our operator account. You can use your account from the Hedera portal. And this account will pay for all the transactions we execute through Hardhat. And then we can specify the default network. So we should not always provide the network when executing scripts later on. So the default network will be testnet. Cool. Next, we need to create our contracts folder. This folder will contain all of the contracts. So we will just create one contract initially for our ERC-721 token. And let's call it ERC-721 mint.sol. There we go. So the contract will be able to create an NFT on Hedera, and it will have a function to mint new NFTs. Let's now go to OpenZeppelin to create a new contract with the mint feature and have auto increment enabled. Okay, so now in OpenZeppelin, let's select ERC-721 contract. I want to use the same name, my token, and the MTK symbol. Let's make the contract mintable. So as you can see, a save mint function is added. And I want to use auto increment ID. So when we want to mint a token, we only need to specify the receiver address, and that's it. And this code we will actually use. You can see that we're importing the OpenZeppelin contracts here, which we have already added as a dependency in our project. So we can just copy code, right top, copy to clipboard. There we go. Okay, so now let's paste the copied code from OpenZeppelin into our contract. There we go. So now we are ready to actually test our connection if it works with Hardhat. And we want to connect to the console through the testnet. So we use the npx hardhat console command and we want to connect to the network. That's called testnet. And this will actually also automatically compile our ERC-721 contract and create all of the artifacts. So let's use this. There we go. And we have entered the console. And as you can see, our artifacts have also been generated. We can exit the console by hitting Ctrl-C twice. And now we can actually take a look at the artifacts. It's generated also a cache. In the artifacts, you'll find the contracts folder. And here you find the following data. Here is the mytoken.json ABI, and this contains all of the inputs for our contract. So for example, the constructor expects an initial owner address, which will own the ERC-721 contract. And we will now start deploying this contract. To be able to deploy a contract, we actually need to create a script folder. And this is the way that Hardhat works. So you can use scripts to do all kinds of actions like deploying or interacting with your smart contract. So let's first create a deploy.js script. And this script will actually contain the logic to deploy our contract. So here is the code. And the first thing that we do is we will use the ethers library to get the signers, and we will use the first signer from this array, which will be the account we have actually provided in our hardhat.config. So it will actually retrieve the following account. We'll print this address to the console just to verify if it's the right address. And then we want to retrieve the contract factory for our ERC-721 contract. This token contract has been called mytoken.json. You can also see it here in the artifacts. And if you go to the ERC-721 contract, we've also called this contract mytoken. So that's where the name comes from. And we need to specify this name to be able to get the contract factory. And then the second parameter is the deployer that will sign for the transaction. And next, we will call the deploy function on our token, and we provide the initial owner of the token. So this is the first variable you saw in the ABI. And then once the contract has been deployed, let's print the contract address to the console because we will need it in the next step to mint a new token. So to execute this command, we will use hardhat again, and now we will use the run command. And we specify our deploy script, and let's specify, just to be clear, that we want to deploy it to the testnet. There we go. So as you can see, our contract has been deployed to the testnet, and this is the address of the contract. Make sure to copy this address, and now let's create a new file, and let's call it mint.js. This will be the script to mint a new token. Let's copy the code again for the script. And as you can see, we will request the signers again, which will give us our deployer, signer. We get the contract factory again. And now we need the contract address. So let's copy the address and replace it by the new address. And then we attach the address to our contract factory. So Hardhat knows which contract we want to interact with. And then let's call the SafeMint function, which we have added before on our contract. And we specify the deployer address, because we want to mint one token to our own account. And then as an extra check, I want to see what the balance is for our deployer address. So once we mint the token, it should be a balance of 1 NFT. So now let's execute this script again, and let's specify the testnet. And there we go. As you can see, we have a value of 1 NFTs minted. And lastly, let's go to Hashgraph to verify if our contract has been deployed. Let's paste in the contract. And as you can see, all of the details of the contract are here. It's an ERC-721 token, the name and the symbol are included, and you can also see the recent contract calls.
Okay, now I would like to enable the burn functionality for our NFT. To enable burning NFTs in your ERC-721 smart contract, you'll need to make a few modifications to your existing Solidity file. Let's walk through these steps. We can go to OpenZeppelin Wizard again and go to our ERC-721 contract to enable the burn function. You can see that an extra import has appeared, the ERC-721 burnable extension from OpenZeppelin, at the top of our file. Next, note that the contract declaration has also been updated by inheriting from the ERC-721 burnable extension. With these changes, your contract has now a built-in burn function that allows NFTs to be permanently destroyed. After updating your contract, remember to recompile it to apply these changes. Run the npx hardhat compile command in your terminal to recompile your contract. You can confirm your changes by opening the mytoken.json file in your artifacts folder and checking if the burn function appears in the contract's ABI. Finally, deploy your updated contract again using the npx hardhat run script/deploy.js command and make sure to specify the -- network testnet because we want to deploy our contract to the testnet. Once your contract has been deployed, make sure to copy the new smart contract address and update this address in your minting script. Now you're all set to mint a new NFT for the newly created smart contract by running the same command but with the mint.js script. And lastly, let's create a burn.js script in our scripts folder. The code looks very similar, except we are calling the burn function. The burn function accepts the token ID which we want to burn. As we have selected auto increment IDs, and these IDs are starting counting from 0, let's specify 0 as the first token ID we've just minted with the mint.js script. To be sure we are actually burning the token, let's print the balance for our account to the terminal, and it should show the balance of 0 NFTs. Again, execute the script with the same command, but update the script name to burn.js. And there we have it. We have burned our NFT for our account and the balance shows 0 again. And that's it, showing the full flow of creating an ERC-721 token using Hardhat, deploying the smart contract, minting a new token, and burning it again.